Good morning, everyone, and let me welcome all the participants here who are largely from the Agriculture Policy and Sustainability Innovation Group, APSI, what we call, and also those who are online. The topic for today is on, it's a brainstorming session. We want to learn more, know more about something called biochar. Many may not have heard it earlier. If you meditate regularly, then perhaps these types of innovative products come out of it. The concept and the topic, I want to take 2 minutes and then I'll introduce the three main speakers who would give us much more knowledge about this. And then we will have two discussions on this to take it forward. To me, the whole issue in agriculture is about profitability of the farmer on one side and sustainability of agriculture on the other. It's not just climate change that is posing the challenge of sustainability, but I think in the race to produce more and to benefit more, we have damaged the basic resource endowment of this planet because we have multiplied so fast as humans. Either you starve to death or you produce more. When you produce more, there are many side effects. Producing more from the same land, from the same water, from the same. So our environment group, Veena heads that, has been looking into four elements of nature: soil, water, air quality, and biodiversity. We have looked quite a bit into water issues, into air quality issues. For the last 2 years, we have been working in about 6 states of India. Soil somewhat less we have probed into, and the soil quality also has been degrading. More of chemical fertilizers that Dr. Nunn came about and started using to produce more of food. But those chemical fertilizers have led to certain undesirable consequences on the soil structure. So we are likely to be putting in more thoughts and more resources into understanding the soil structures and how best we can improve upon or at least arrest. To me, our soils are largely about 60% of them already in intensive care unit, ICU. Now, when we talk about this topic and this biochar, we look at 3 points. And this is where my request to the speakers would be. One is a product. So you have developed a product in some new form, which is an innovative thing. How do you do that? From product to practices of the farmers. How do we convince the farmer to change his farming practices? That's one major element and big challenge. Because farmer has to see his profits. Bottom line is, मेरा profit क्या होगा इसमें, मुझे क्या? I mean, our interaction with the farmers, everybody understands the problems. But if you tell him to change his practice, which compromises on his profits, so how do we move from product to practices of the farmer, farming practices? But if it has to be a scale, one success story in this place or that place, working with 100 farmers, 200 farmers, 500 farmers, they give you pilots. and you need to move to policy for a nationwide impact. So products, how it is being made, how are we changing the practices of the farmers, and how we think we can change the policy. Because if we have to change the policy, we have to convince the policy makers of the pros and cons of this new product. So an independent, transparent inquiry into what the benefits are to the nature and to the farmer. So you have to take care of peasants' profits, you have to take care of national productivity, but also you have to take care of planet's health, soil in particular, water, that is something. So if we can do this and empirically create a case from our pilots that productivity is not compromised, profits are not compromised, in fact, they increase, and therefore it makes a case for policy change. And what sort of policy that should be? You need an innovation in the policy making also. And that is where our role, our center of excellence that we have here of agriculture policy, sustainability, and innovation, OPSI it is called. So that's the way we look at it. And we very much look forward to hearing your words of wisdom and the technology and how you brought it about. Let me introduce in one go our three main speakers. Dr. Sriram Raghavendran is head of the Agriculture Center for Excellence, a joint partnership between Samunnati and the Heartfulness Institute. So you have to have compassion. His primary initiative in this capacity has been to explore and roll out biochar production as a rural entrepreneurship model. In partnership with ICAR, corporate partners, and FPOs, he has worked on setting up biochar facilities at various sites, running biochar farmer trials, and generating high-value carbon credits for biochar sequester in the soil. His vision is to set up a biochar unit run by rural entrepreneur in every village of India as a means to rejuvenate the soils of India and the world. And we are very much into the soil business. So if this can be done, it's a dream. If it can be really realized, nothing can be better service to humanity than ultimately we are buried in soil and also eat everything that comes out of soil. Dr. Meenu Tiwari is Professor of Economic Development at the University of North Carolina at Chapel Hill and Director of the Modern Studies Initiative there. Our research focuses on the political economy of development, political economy. So that's where the policy making will be. Global value chains, good governance, and institutional reform in cities and critical infrastructure such as water in the context of changing climate. So you have the soil, you have the water, knowledge, and Mr. Sunil Dhingra, director at Biotrend Energy, is a seasoned expert in clean energy, specializing in biomass, bioenergy, and low carbon development. With decades of experience in sustainable energy transitions, he has worked across India and internationally in policy advisory, project design, and strategic implementation. He brings a strong foundation in technical and policy expertise to support scalable renewable energy solutions. So you will have soil, water, energy, and scaling up of the experiment. I think the way we have kept this, Dr. Meenu Tiwari would set the stage, and then you would take the stage for detailed presentation. After that, Sunilji, and then we have two in-house discussants, Reena ji, Dr. Over to you.
Thank you very much, Professor Gulati. It's an honor to be here, to be discussing this topic with all of you and to see where it will take us. You've already talked about soils, and according to the United Nations Office of Disaster Risk Reduction, about a third of the world's soils. And for India, they put the number as 30%, but you're saying nearly 60% is in the ICU. So these are currently classified as degraded, impacting almost half, more than 40% of the world's agricultural lands and agrarian communities. So this degradation is, of course, due to several factors, such as extensive fertilizer use, water and wind erosion, depleting water tables, parched earth in some places, salinity, acidification, of course, poor soil management practices because people are under so much pressure and finances are low, and vegetation loss of all kinds, and many other reasons. The problem here is that all of this has a domino effect. And this cascading effect impacts not just a particular plot of land, particular agrarian community, but ecosystem. And of course, rural livelihoods that will only be worsened by the mounting pressures of climate change. So the problem is dire and the problem is very current. On top of that, this agrarian and ecological distress is compounded by the ongoing loss of agrarian lands to industrial and urban encroachments. We see that happening everywhere, and large-scale land grabs. The modern version of it is acquisition for mining, lithium, and other things. Energy even, good things, renewables take a lot of land, and other extractive infrastructures. So things are dire, but amid these troubling transitions, there are experiments, there is hope, and innovations that could potentially reshape ecologies in ways that can remake agrarian futures in powerful ways. So one such innovation is the growing awareness of, and indeed revival and adoption of biochar. So what is biochar? Biochar is an ancient practice. It's an ancient product. It has very old roots. Thousands of years ago, residents of the Amazon produced biochar by heating up organic matter in controlled conditions. And sometimes it happened naturally because forests burn. And then they're so thick, there's low oxygen. It just so happens. And that created rich, fertile soils called the terra preta. And this practice, which helped them a lot, was then abandoned during the European invasions of Latin America, only to be then later revived in the 2000s in the context of climate change and a search for carbon neutrality or a way to sequester carbon and restore soils. So in 2015, 2016, there were some seminal papers written in Nature and Science journals about biochar. The experiments were happening around the globe, and people were looking at it as a way to kind of do something about climate and carbon. Agronomists since have shown that biochar combined with microirrigation and charged with nutrients, farmyard manure, other kinds of things can remediate soil, get rid of soil pollution, restore soil health, conserve water, which is scarce as well, and augment crop yields, which can increase farmer incomes while lowering their costs for use of other kinds of fertilizers and weedicides, while sequestering carbon for years to come. So this sounds too good to be true. And if this is true, then why aren't more people adopting it? And that's exactly what this conversation is about. That experiments happen, innovations happen, but how do you implement them in institutionally viable ways, economically viable ways, at scale and sustainably, so that farmers adopt it not out of pressure or out of coercion, but because they want to, and that there's a triple bottom line there. So today we'll hear about at least a large-scale experiment that has been successful over the last 8 years in Kana Shantivanam in Telangana and beyond. We'll talk about the hills of Shivgarh, for example, and explore the promise that this particular intervention holds and the questions it raises, as we said, about implementing them on the ground to ensure economic viability, scale, and sustainability. And I just want to say that biochar is not a silver bullet. It's not an isolated thing. We'll hear from Mr. Raghavendran how it's embedded in a whole set of practices that have to do with water, that have to do with afforestation, that have to do with community development and many other things. With that, I'd like to invite Mr. Raghavendran to take us forward.
Only one clarification. There is no difference between what you were saying and you said 30% land is degrading.
Yeah.
I was saying 60% of our land actually has soil organic carbon
Yeah.
less than 0.5,
Um,
which is literally ICU
That's true.
condition. That's where we need to increase the carbon content. It's a definitional
Yeah.
question.
Right. And that is exactly what you'll talk about.
So,
Thank you.
Thank you, Meena. Thank you, Dr. Gulati. It's really an honor and privilege to be part of this session. Thank you for the opportunity. And I think it's timely because the kind of problems that you were talking about, I do believe, though my experience in this has been limited to 2 years, but it's been my passion and this is the only thing I do.
wonderful.
And it seems to be right at the cusp of many of the problems that we're talking about, right? And what I plan to do is kind of walk you through a visual narrative because I think it
Wonderful.
speaks to us.
Yeah.
And we'll see examples. Okay, we'll see a little research. We'll see the results, the promise, and the challenges,
Yep.
right? And the challenges has to do with awareness. That challenges has to do with policy. So I'm really glad that you talked about product. You talked about practices. Which is what we're working on. But we can get it started on our own two legs. But clearly without policy, it will not scale. So I think you really put it nicely, and I believe what we're going to talk about will exactly follow that space. So I put up the slides and have it click up. The third one on the right. The next one. The forest by Hatfield. So Forest by Heartfulness, this is the ecology and environmental initiatives from Heartfulness Institute. But a word about Heartfulness Institute itself. It is global today. It's present in about 160 countries. It's a non-profit organization, essentially offering a practice of meditation, what we call heart-centered meditation, right? And like I was mentioning, until 10 years back, this was exclusively a spiritual organization offering meditation, word of mouth, no PR, because we don't charge for meditation. It's free to one and all. Everybody can practice, right? And find it's basically promotes inner transformation and inner development. That being said, in the last 10 years, seems like we've switched gears. Okay, we work with any institution. It can be corporates, it can be colleges, schools, wherever people come together. Excuse me. We offer meditation, right? And today, in addition to meditation, okay, we offer something like we work on about 200 plus social impact initiatives in the areas of environment, education, health and wellness, livelihood, and research, right? So these are the areas in which we work on. Today, we'll be focusing exclusively in the environment space, right? Some of the things, to this audience, I barely need to talk about the challenges, right? And what's here is only a sampler of the kind of problems that we're facing, right? I've only picked up conveniently, a few problems, which are being addressed by the initiatives which Forest by Heartfulness runs. Forest by Heartfulness runs something like about 30 odd environmental initiatives. Okay, a lot of it in the area of water, a lot of it in the area of greening, afforestation, endangered species, and biodiversity. Okay, but also in soil health, right? And we don't see this as individual initiatives, right? But when we're able to collectively run this out of the same institution, in some sense, the power of overlap, and integration is really what's really gives it legs, right? So while there is blue, which has everything to do with water, I hope that at some point in time, I'll have an opportunity to share on that. And green, we're doing extensive afforestation. But today's story, we'll restrict it to black, which is biochar. But the narrative starts with a story. Okay. And this story is about the headquarters of Heartfulness Institute. It's about 30 minutes away from the Hyderabad airport, okay, away from the city. It's about 1,400 acres.
Mhm.
And when we started acquiring it 20 years back, a non-profit organization like us could acquire about 1,400 acres because land was worthless.
Mhm.
Water table was about 1,200 feet below ground.
Mhm.
Agriculture had come to a complete stop because of extended drought for about 6 or 7 years, right? And that's the one reason why an organization like us could acquire a large parcel of land, right? One single land of 400 acres plus about another 1,000 acres, all in a vicinity of 3 or 4 kilometers, right? Soil was poor, water table was very low, 1,200 feet below ground. Soil is very porous, red soil. Even if it rains the next day, you can't even find any dampness in the soil because water just percolates into the ground, right? Soil organic carbon is very low, right? I mean, I'm kind of reminded, I'm a science fiction buff. Okay, I'm reminded of the Foundation series, right? Where, I mean, Sheldon, sets off the new foundation, okay, in Terminus, right? A planet like, almost absolutely no resources, and that forces innovation. Like, how can you eke out a lot from nothing? Okay, it seems as if, in hindsight, perhaps that's the kind of situation we got into. So work started in this place in 2015, right? Some basic work, and you can see how the land was. There were barely about 200 trees, neem trees and babul trees in the whole place, right? And this is to 2019, right? And where the road started coming up. And I've been visiting this place for about 20 years, right? I've been practicing meditation myself for about 35 years since I got out of college, got into college. And I thought, like, in such a place where there's not even a tree, why don't we start with trees? Why do we start with more concrete, right? And I was thinking, like, what the heck, what are people doing, right? Little did I understand at that time, and only in the last 2 years when I live on this campus, did I understand that the first thing that you need in a journey like this is water, right? And the roads, the concrete roads, which run for a couple of kilometers in each direction, they every 50 feet has a rainwater collection point. Every 100 feet has a rainwater harvesting pit. We have about 800 harvesting pits. And you saw, the topologically, the lowest areas on the campus, either got rejuvenated, the lake got rejuvenated, or new lakes were created, established, right? And so the creation of roads was foundational, to actually improving the water table. And even how we carry water from the roads to the lakes, right? Every bit of the way, water is sequestered, water is harvested, right? It's only the overflow that goes into the lakes. And this was 2023, 2 years back. Okay, today, just to contrast, okay, we have, I'll continue, right? I mean, there's a lot of development. So road like this, poor soil, and this is the kind of trees that we have today. So today, this is Kana Shantivanam, right? This is absolutely green campus, okay? And really the core of this work, the back was broken in a period of 6 years, right? And what has changed, okay, in this, okay, I'll again go there. So now today we have 9 lakes, okay, which collectively has a capacity of 500 million liters of water, right? Water table is up from 1,200 feet below ground to about 100 to 300 feet below ground. If it's summer, it's 300, sometimes 400. Okay, but in monsoon, it's about 100 feet below ground. We have planted about 1.5 lakh trees and innumerable number of shrubs, right? We've even created a rainforest there. Okay, rainforest is the semi-arid lands of Hyderabad, which barely gets 400, 500 of rain each year, right? And 1,500 families live there. Agriculture is back with a bang, not only in Kana Shantivanam, but across the 50 villages which surround there. Because when we increase our water table, okay, it not only helps us, but it really impacts the whole community, right? So this is the transformation. This is the rainforest. It was a challenge, right? Daji, Kamlesh Patel, who's the spiritual guide and the president of Heartfulness. So he challenged our forestation team to create an Amazon forest or create a rainforest, right? And there's a Dr. Ramakanta, who's an ex-IFS officer. Straight off the bat, he's written books, he is an expert. He said, no way, you can't keep evergreen species here. It will not come, it'll die, right? And when he insisted, right, this was created, okay, more as an experiment, right, to see what kind of hacks we can develop. And today, okay, evergreen species, about almost 100 plus species, like, are growing and thriving, okay, in Hyderabad, right? And that kind of soil, right? So it takes a lot to build a forest, and that to an evergreen forest, right? And arid landscapes like this. I would say again, three things, right? First, water. Okay. Second, soil. The third one is, okay, plantation and afforestation, right? And all of this, like, is really what Forest by Heartfulness does, right? And when you have 100, 200 species of trees, it automatically brings back biodiversity, right? In 1 year back, we measured, somebody's counted about 120 species of birds, okay, which have been sighted in Kanashantivanam, right? Where there were not even literally 120 trees on campus, right? So this is the transformation, right? And so the question is, like, so what? Okay, big deal. Okay, India is so big, the world is so big, like, 1,200 acres, 1,400 acres. Yes, there's been greening. So what's the big deal, right? So it always starts with a drop and then the ripples expand, right? And what we've done there, okay, for about 6-7 years, all that we did was to learn to work in our own home, our own backyard, right? And the first opportunity to step out of Kanha came in 2022, where a small 30-acre land, like, which is hilly terrain, like, which nobody could green in Madhya Pradesh, came about. And then Shivraj Singh Chauhanji, who was a chief minister, came to Kanha. He saw and he invited us. And he gave this particular parcel of land. Sorry, so this is a 2,000-acre land, okay, it's a forest land, quote unquote. Okay, there's obviously no forest or trees there. It's a complete barren land. Okay, it's almost like my head, right? I mean, literally devoid of anything, right? And it is this rocky terrain, like, which was given to us to develop, right? And this was the challenge we took up in 2023. April was when we started, right? And this is exactly it's in Ratlam. It's in the middle of Delhi-Bombay highway. Fast forward 18 months, right? This is how the place looks, right? Again, thanks to our experience, the first work that we started with is water. Okay, in a period of 1 year, we built about 36 earthen check dams, okay, all interconnected, right? And collective harvesting about 29 crore liters of water. And in the 2 years, okay, with CSR funds, whatever little we've been able to garner, we put in about 2 lakh saplings, okay, and we do expect, like, that this will become a very beautiful forest, right?
Using biochar.
Using biochar. Okay, so this kind of
Biochar तो अभी बोला ही नहीं आपने.
so from now on, everything will be biochar. So these kind of afforestation projects, Kanha projects, right, where the soil is poor, terrain is poor, low on soil organic carbon, right? I mean, with biochar alone, we can't do anything, right? You need water, you need soil, and you need, like, greening practices, right? So today, I think we were interacting with the International Biochar Institute based in the US, right? It's again a knowledge organization. They were referring, they said that if you've been working for biochar for 8-10 years, okay, much before carbon credits came into being, which is what got everybody excited, you're probably the oldest, okay, and if you're doing 10,000 acres of afforestation with biochar, you're probably the largest case study of biochar in the world, right? So that being the case, okay, 2 years back, and this is where I came into the picture because I was a tech guy, I'm now completely dedicated to biochar, right? We said that if this is the effect that we see, and I can tell you our afforestation projects, we our standard for sapling survival rate is 85 to 90%. And I believe, like, that is because of biochar, right? We've seen that so much of success we've seen because of this. Why don't we pivot to agriculture? And that's what I've been working barely for the last 20 months, right? So, and again, why biochar for agriculture? We believe that this can really regenerate the soils of India and the world, right? So what is biochar? Okay, I'll just take a couple of minutes at it. It's basically, right, I mean, when there is wood, okay, which gets buried in the ground, right, nature converts that to coal over thousands of years, right, at very low temperatures, 50, 60 degrees, right? The same thing, biomass, India produces 500 to 600 million tons of biomass every single year. And each of that biomass, every carbon element in that biomass, okay, is sequestered from the atmosphere, the bulk of it, right? And when we burn it, when there's open field burning, everything goes back, not just as carbon dioxide, but as methane and nitrous oxide, right? But when we're able to pyrolyze it, which means heated under low oxygen conditions, okay, it becomes biochar. It's nothing but charcoal, coal, okay, but we can get it converted in an hour or two. Okay, that is the difference, right? It doesn't require millennia. These are okay. Right off the bat, I know Sunil is going to talk more about equipment and manufacturing process, right? Right off the bat, I will say that there are two ways to do it, right? One is very low tech biochar, which every farmer or an entrepreneur in a village can do. The other one is high tech biochar, where here in low tech biochar, there are some emissions, but research has indicated that harmful GHG emissions are negligible, right? But there is also a high-tech way of manufacturing biochar, okay, which will cost millions of dollars or crores of rupees. Okay, we're trying to get it to lakhs. Okay, but okay, so these are different. This is for industry and this is for village. What we've started in the last 18 months is low-tech biochar. We're moving to industrial biochar. Right? This is a very simple facility that's been set up, okay, with some farmer groups like in Madhya Pradesh. So this is what happens. You see cotton stock in the back, at least like wheat and paddy, like, maybe it becomes cattle fodder. Cotton is typically burnt, right? I mean, I've been in Madhya Pradesh and Gujarat for the last 2 years. In the harvesting season, anytime I look out of my window driving for 3 or 4 hours from the villages to Indore, I see fields burning. Okay, this is everyday business, right? But when we're able to pyrolyze it using this extremely low tech equipment, you can even do it in pits in the ground. You don't even need a metal kiln. You get biochar, and then this biochar, right? If it's cotton, we get anywhere from 60 to 70% carbon. Lantana, which is a huge problem of infestation, invasive species, we get 75%. If it's prune wood, you get 80% carbon.
Little clarification.
Yeah.
I've been struggling.
Yeah.
When we were little children.
Yeah.
There used to be kacha koila.
Yeah.
Right? Every market used to have coal because अंगीठी था, gas वैस तो था नहीं उस जमाने में.
Yeah.
तो अंगीठी में पक्का कोयला भी होता था और कच्चा कोयला जलाने के लिए. What is the difference between kacha koila and this biochar? It's the same process.
So depending on the process we adopt to manufacture biochar, right? The quality of biochar can either be kacha or pakka. Okay, the technique in the low tech, in the high tech, if you fill it, shut it, forget it, and you will get high quality biochar.
Okay.
In the low tech process, okay, the devil is in the details. So how you adopt the process, and typically we're doing it with unskilled labor, but the ability to follow the process and the few techniques can give you either very high quality where there is no piece of cellulose or wood at all, or you get extra, or you get like kacha, so it completely depends on the level of attention to detail, right? But the calorific value is high, okay, and it's extremely porous. Okay, I think he has some samples. We look at it, right? So you can see, like, it's completely black, okay, and even if you have done it with wood from petties, okay, so you can just it's crushed in a hand, it's so porous, right? And porosity is everything, right? Now, my focus is not on the production process. I assume Sunil will cover that.
Yeah.
Okay, but it's in terms of what do you do with biochar and what impact does it have, right? When it's blended with organic manure, okay, it could be poultry, it could be compost, vermicompost, whatever. And when it's fortified with microbial consortiums, right? And we either do on the top, you see agricultural, it can be broadcasted. It can be put in line applications, or if it's afforestation in the pit for large trees, we put 2 kilos. For a small shrub, we put 1 kilo, right? And there's a process for all of this, right? And the results are fantastic, right? What really works in biochar? I'll just talk about three, right? The three differentiation, right? It's highly porous. What you see on the left is a picture from an electron microscope, right? There are nanopores, micropores, and macropores, right? And these pores basically increase the surface area of carbon in the soil when applied to the soil. Okay, and it's measured that every kilogram of biochar, okay, has a carbon surface area of 100 acres. So how much do we put? Our recommendation is to put anywhere between 1 ton to 4 tons an acre, right? We'll come to the cost a little later, right? But if you're talking when putting 1 ton, you're talking about adding 100,000 acres of carbon surface area to the soil, right? And we all know that, carbon and surface area, right? I mean, these are building blocks for microbial life. And when you saturate this biochar, it could even be with Jivamrut, but it could be mycorrhiza or azotobacter or whatever, right? More sophisticated microbial solutions. And when we put it and when we mix it with compost, which becomes like, basically food for the microbes, what we see is an explosion, okay, of microbial life in the soil, fungi in the soil, right? and they actually restore soil fertility. Right? And the last thing, and this is, I think for me, it's insane. Okay, that biochar, once it's put in the soil, it's sequestered and inert, which means for thousands of years, they say 5 to 6,000 years, biochar remains inert in the soil, which means it's very clearly it is not a substitute for fertilizer. Because if it's a fertilizer, it gets consumed, right? हम जीवामृत है, compost है, यूरिया है, DAP है, हर season डालना पड़ता है because it gets consumed, right? The second season you'll grow nothing. But once you put this, it doesn't provide fertilizer or nutrients, but it creates an explosion of microbial life, and that in turn, microbes, once it comes back in the soil, they fix nitrogen, right? They solubilize nutrients and make it available in the soil. It is also, there are physics, that's the biology part, there's a chemistry part and the physics, right? The physics part is that like it acts like a sponge. Okay, so it absorbs water, and 2 or 3 days later, like when the soil gets dry, like capillary effect, little by little, it keeps, like you said, ICU, little by little, like it keeps giving water and nutrients, right? So the fertilizer use efficiency goes up, the soil, what do you call, the moisture goes up, and these are like game changers, right? And I'll talk about the examples. The last thing is, today, okay, we're talking about carbon sequestration. While nature-based solution of forestation is the big thing today, it is not permanent sequestration, because like Los Angeles fire, if there's a fire, like it just goes up into smoke again. But once you've converted even farm residue into biochar, you put it in soil, and if it remains there, they say that 25% of the biochar that you put in soil, right, degrades or degenerates over 350 years. The rest of it remains in the soil for 5 to 6,000 years, right? So once you put it in soil, okay, it's permanent, okay, and there's no way of getting it out. And the IPCC assessment in 2022, it says that biochar itself has the potential, like, to sequester about 2.6 gigatons. And in terms of net emissions, there's a huge number, right, every year. So this is all fine, right? This is theory, right? Hey, what have you done with it, right? What has been your experience, right? We started experimenting, with our own organic fields, like with biochar, and this is where, like the bulk of our experience comes in, right? And small experiments, right? I wouldn't call it research trials, these are just field trials, but you can see, like the root, the thickness, the growth, okay, everything increases, like with biochar. Okay, I'll just give 3 examples. There's a first experiment, tentative experiment. You can see on the left, there is no biochar. On the right, on the amaranthus, there's biochar, right? And in terms of, we saw that between no biochar and biochar, there's almost a doubling, okay, in amaranthus, because it's leafy vegetables. When it came to cluster beans, 74%, tomato, 48%. I wouldn't say that these numbers are replicable in every soil and every way, right? But it's kind of indicative. We're just starting our first experiments, right?
But in control, you're adding fertilizer.
Compost. Compost is added, and what we added in the this one is, like additionally biochar and, like the microbial solutions. This I will tell, right? I'll go to the next one, right? Because these were our first trials, right? Don't read too much into this. I'll go to the next one, right? But some of the observations, I think this also were founded in farmer trials. Germination rates improved. The vegetative growth, this is crazy, right? I mean, that I had these 4 control, okay, and little biochar, more biochar, even more biochar. In the one with the highest biochar, it was like as if it was Usain Bolt, right? The growth, okay, when we put the same kind of plants, okay, the growth, the vegetative growth, like even on day 5, they had put it in my absence. I came back on day 5. I went there 9 o'clock. I saw it. In 5 days, 1-month-old saplings put on the ground, I could see a significant difference, right? So that vegetative growth grows, that's on the top right. Flowering, okay, starts about 8 to 12 days early. This we found in tomato. This also we found in cotton. Okay, and
it's again one clarification. This is biochar. What you say composite?
It's compost. You never put biochar directly on the soil. You're not supposed to.
But did you have the run where you are whatever you are adding, compost or bio?
Compost is in both.
Only with that, without biochar.
Yes.
Have you had a run with that?
I'm coming in the next slide, sir.
Because that will be a
that's a comparison.
Yeah, minus biochar.
Yeah. So these are my initial trials, right? But this is the farmer trials, okay, which we ran last year. This is in cotton, okay, that we ran. And you see on the left, so the farmer trials, ran like this, right? This is across 3 districts, 2 in Gujarat, 1 in Madhya Pradesh. Okay. And the Gujarat farmers were what you call conventional farmers with DAP, urea, and potash. Whereas the Madhya Pradesh farmers, were organic farmers, right? And about 144 farmers. And the remit, what we told the farmers was that whatever you're doing, right, you do it in half acre. Okay. In this half acre, okay, you add a biochar mix. Okay, this is the difference, right? So in organic farms, okay, they would put the compost there, Jivamrut there, they would put here, they would put the biochar mix, which has the compost mixed, okay, and the Jivamrut and the biochar, right? And the vegetative growth, this was the difference. And this we partnered with Central Institute of Cotton Research, okay, in
But
Nagpur.
no standalone biochar.
No standalone biochar. See, the point about biochar is, okay, if you put standalone biochar, which is not saturated, it is so porous and so thirsty that whatever nutrients, whatever fertilizer you put, whatever water you put, it will absorb and deny it to the plants. So it is actually a recommended practice that you should never put biochar, which is dry, into the soil. You always saturate it, okay, with Jivamrut or any of this microbial consortiums. And because these, once you saturate it with microbes, they need food to eat, and so you mix it with compost, right? So you always, these 3, okay, is the basic set, okay, that you put into the soil, and it's applied once basally, okay, about 2 to 3 weeks before you do the sowing. The beauty about this, unlike organic practices, what I understand, right, it's not a whole lot of change. Once ऐसे compost डालने वाला है, वो तो sowing के पहले डालने वाला है. And but instead of that, you mix it with Jivamrut and no biochar and mix it with compost 1:1 or whatever. And you put it basically, close it, leave it for 2, 3 weeks, do the sowing. Zero change after that, okay, or any further intervention. Right? I'll show you some data points.
How do you make Jiva Amrit? You will have to explain.
Jivamrut is like, a microbial fertilizer, which is there. Most of the organic places is standard practice. It has 5 elements, right? It has cow dung, cow urine, jaggery, okay, and sometimes they put basin and local mitti, okay. And there is a certain proportion. And most of the farmers, they'll have access to Jivamrut, and you can take a little bit of Jivamrut, okay, and you can expand it. Okay, you can put 20 liters of Jivamrut, and in 7 days, you put some jaggery, you put some additional chana dal or whatever. It actually becomes 1,000 liters, right? So it's something which it's like dahi. Okay, gar pe, you can take a little bit, put it, and it becomes more. It's like that. Right? So this is the result, which came from a 6-7 month cycle. Okay, this was where Central Institute of Cotton Research was involved. Madhya Pradesh, okay, we had 70 farmers, okay, in 10 villages. They were all organic farmers. This is organic cotton belt. Okay, and this we worked with a company there, okay, called Pratibha Syntex. Whereas in Gujarat, we worked with Arvind Mills, one in South Gujarat and one in North Gujarat, right? And if you look at the quantitative data, right, and this is over 7 months, the yield in the 3 districts, right, they were up by 15%, 26%, and these 2 are in conventional farmers, and 33%, and this is in organic farmers. But in terms of plant height, in terms of sympodial branches, in terms of length of branches, the number of flowers and the number of balls that we got, okay, all of that increased, right? There is definitely some problem in the last one, that's called Biochar, okay, where the data collection, right, there seems to be no causal effect, right, in terms of plant height and sympodial branches, but the results are there. There's definitely a data issue there. But in the other 2, it's very consistent in terms of the overall from start to finish, we could see a difference. Right? And this year, we plan to expand these trials, okay, and actually get better. This was the first season that we did these trials.
You'd like to talk about the farmer response, what the farmers reported.
Yeah. So on the top left, right, the farmers reported, okay, and these were the non-quantitative or subjective measures, right? And this is very interesting. First is there's a clear difference, okay, like you saw on the previous slide in terms of vegetative growth. Farmers found the leaves were greener, which means they're getting more nitrogen, right? And because the soil remains moist, one farmer, when we went there with the soil scientist from CICR, he said that we had told them strictly, right, that the 2 half acres, with and without biochar, no change in practices. But farmers do what they do, right? By about 6-8 weeks, they had already figured, okay, and this guy said, देखो भाई, मैं तो दोनों जगह में drip डाल रहा हूँ, okay, And in one, I put 3 times a week, I put 8 hours cut drip. Okay, but in the biochar field, I reduced it to 5 hours because मुझे पानी का problem है, right? So I'm only putting 5 hours. But I find that on the second day or third day, the one with biochar, even though I only put 5 hours of water, this soil remains more moist. And when the soil is moist, I think it's a game changer because the roots are able to go deeper, right? They access more nutrients. Deweeding is easier, and deweeding is a big expense, okay, because the soil is hard, like deweeding is very difficult, okay, and because the roots go deeper, okay, the stalk is thicker, the vegetative height is higher, and this is like, for me, it was difficult to believe, but it was obvious, and farmers were saying it, is that even though the control plot and the biochar plot were next to each other, the incidence of pests, okay, or the pest attacks, right, is not that the pests were not attacking, but the resistance, the immunity of the biochar crop was better. Okay, and this is what farmers reported, right? So I was just trying to bring it to, so what actually happened, right? The first and most important is the physics property, right, where a 1 kilogram of biochar can hold about 3 to 3.5 liters of water and nutrients. That depends on the bulk density. Okay, if it's cotton, it's 3 to 3.5. But let us say if it's lantana, it might be possibly 1:1. I think once the water and nutrients are retained, there is a lower water requirement, right? In this case, if you're talking about 5 hours to 8 hours, that's a 37.5% reduction in water usage, right? So better water utilization, better fertilizer use efficiency. And this increased soil moisture, I think, is a game changer because lesser effort and cost in deweeding, higher vegetative growth, earlier flowers, right? I mean, the soil scientists, when the farmers said that flowers were coming about 8 to 12 days early, this soil scientist and biochar scientist from CICR, he said, this is different because every 3 days in cotton, there's a new flower which will become a ball of cotton, right? So if it's 10 days early, then it results in 2 to 3 additional balls, right? And that's what resulted in higher returns, right? And the yield is directly proportional to the income as well, right? But this is not the end, right? This is the first season. We have not done this, okay, but there is another company called Mash Meeks. We were talking with their research department, and they've done, okay, 5 seasons. They've applied biochar once in soil. They've applied 2 tons. We only tried 1 ton. They tried 2 tons. And 4 tons an acre. They have two models. But once they've applied, they've measured for 5 seasons. And second season, no intervention after the first season, right? And they found anywhere from 4% to 90% increase. The example they were giving me is they're able to see a consistent difference year after year, season after season, where biochar has been applied, right? So
Biochar along with Jivamrit.
it's always a combination. So biochar mix, let's call it. Biochar, Jivamrit, or whatever microbial solution, and compost. Okay, and compost you need to put year after year. But once you put enough biochar, you don't need to put it year after year, right? So this is
It's all
Like
organic.
one time.
all organic, 100% organic. Yes. But the thing is, you can put this organic mix in the with DAP urea also. There is no, it doesn't compete.
And is it one-time application?
So that's what we, our protocol, it's all still evolving, right? It's an early stage. What we would say is that, like, over 5 years, put 3 or 4 times. This was our recommendation. So effectively, you'll get to 3 to 4 tons an acre of biochar.
And for example, say 2 tons per acre every time?
No, that's what I'm saying. You need to load up from whatever little tribal knowledge is available now. It seems as if every acre of land, if you can load up about 3 to 4 tons of biochar, okay, there are people who are doing it one time. We were recommending over 3 or 4 years, but maybe two tons, do bar dalo, bas hai, right? But this is where, like, the practice is, right? This is very, very early stages, right? We've got to really do scientific trials, and I have a recommendation for that.
As a theory point of view,
Yeah.
I think the one-time application should be fine because it's the inert carbon is there, so it is not baking.
Yeah.
So
There are two schools of thought, ma'am. The soil scientist says that, there are papers, there are tons of research publications, right? They say that too much of application in one might be a shock to the soil and a shock to the plants.
Indigestion हो जाएगा.
हो सकता है. So the question is, what is too much and where does the shock come? This is where I think actual research is required. There are people who applied 60 tons of biochar, 20 tons of biochar in the soil, right? So That's where see, I think soil is complex, agri is complex. So you're talking about soil, you're talking about the SOC, the soil testing, like, you're talking about crops, you're talking about water quality, farmer practices, chemical or organic, type of irrigation. So the kind of data points, I do believe, like, a large scale trial needs to be done before we can say with certainty, right, that this is the recommendation and this is the practice. I have a suggestion for that coming up, right? Two or three more slides, I'm done. So while we've been doing this for 6-8 years, for agriculture, we only started Jan of last year, the small experiments. I wouldn't even ask you to go look at that data and dig in, because I don't believe in those numbers. It's very small scale trials we did, but it kind of encouraged us to go forward. So 2024, we set up 6 sites, okay, with Arvind Mills and two cotton companies, fabric companies. Okay, generated about 250 tons of biochar. We generated some carbon credits. We sold a little carbon credits, right? Still very early in the journey, right? 2025, okay, this year, as of yesterday, we've generated about 1250 tons of biochar. Okay, my expectation is we'll end up at about 3,000 tons of biochar. Now, a Heartfulness Institute has set up an entity, like, which is now a carbon credit agency. Okay, we generate carbon credits. We're looking to sell it, right? That's where we are. And in terms of industrial biochar, we've only been the last 2 years working on what you call artisan or low tech biochar, but we are working on and targeting to set up an industrial biochar unit this year. Right?
So each ton of biochar, how much carbon it is sequestering? Because you have mentioned that you have generated 6,000 carbon credit. It's from the 250
Exactly.
tons of carbon.
So
So
okay.
what's the
So
calculation?
it's based on 2 points of detail, right? One is what is the percentage of carbon in that particular biochar, right? A thumb rule is that if biochar has about 75% carbon, and you can do a CHNS analysis, right? So at 75% carbon, every ton of biochar gets you 2 carbon credits.
Okay,
Okay, and the cost of per carbon, the value of each carbon credit could be between $100 to $150 each. So I'll come to the model.
It's converted to carbon dioxide.
Exactly.
That's why this.
The molar.
Carbon is 12, carbon dioxide is 44. That is the ratio. It will be 3 times.
Yeah.
Carbon credits.
So at 75%, it comes to 2. That's a good thumb rule, right? So we've set up a center of excellence, it's a startup facility, right? It has 4 parts. First is like, we can do demo plots and demo trials, for our own experimentation. We have an entrepreneur and farmer training center. We have a biochar production facility and a biochar processing facility. It's going to set up a small biology lab, right? This is where we are starting. We're hoping we'll scale it up. So how do we scale this? Okay, the third part, right? Last year we tried a village level model, right? Like I said, the big units, okay, each is 400 kilos. We bring the biomass from the village in a tractor, centralize it, and at a village level you produce it. But there, like, because there's a lot of non-value added activities, you send tractor, you send people, you collect biomass, you bring it, you manufacture biochar, send it back, So the cost was kuch bhi karo, like, it is not coming below 12,000, right? Sometimes even 20,000 rupees, right? And that's too much for the farmer per acre, right? Now, this year, I think innovation and grassroots level innovation.
So from 1,000 tons of biochar, your biomass, you're getting 300 tons. So it's working at a 30% efficiency, right?
1,000 tons of biomass, yes, 1:3. That is correct. That is correct. But what we've manufactured this year is about 1,200 tons of biochar. So which means we would have worked with about 4,000 tons of biomass so far. Right? So the key is, right, here last year, okay, we did about 12,000 tons, we couldn't get better. This year we said, like, why all this inefficiency of bringing biomass, right? And then 1:3, you have to bring 3 tractor loads of biomass before 1 tractor load of biochar can be done. So we basically have created smaller kilns. Okay, we've experimented with the design. We're sending people, it's still manual. Okay, we're sending them to the field where the biomass is available. There itself in situ in the farm, we're converting it from biomass to biochar, right? And this we find that costs have come down to 8,000. We can even get down to 5,000, I believe, right? So this is much more affordable, right? But this is the key, right? I mean, in terms of an early adoption strategy, right? If I want to run this across 10,000 tons, right? Where's the money going to come from? Right now, companies are giving it, right? But I believe, like, if you're able to monetize the biochar carbon credits, right? And the industrial carbon credits are selling more readily. Okay, we know that. Okay, the artisan carbon credit, there's still, like, a lot of questions, right? But we're exploring, right? But if we can monetize carbon credits, okay, I don't know, it will not regenerate the soils of India, but at least to get this on its feet, we believe that, like, the carbon credit value, monetization value will more than pay to provide the biochar free to the farmers. Maybe for the first, I don't know, 100,000 acres, right? I mean, and then the market would saturate perhaps, right? So the idea, what we are trying to do is to generate carbon credits, sell carbon credits, and use that, like, to see if we can actually provide biochar free to the farmers. Before, let's say we have enough proof points, policy kicks in, and the government also, like, provides support for this, right? So these are the hurdles to overcome. I mean, monetization of carbon credits, still very early market, right? The production methods, we need better engineering there. Okay, how much do you apply per soil, right? With soil, like, what crop, like, what do you amend it with? Okay, which has the right nutrient combination? More research required, entrepreneurship models, and awareness, right? There's almost nil awareness, right? But one thing I can say is, like, in the Gujarat and Madhya Pradesh where we've done, I had a meeting with 20 farmers in Sabakanta, right? And people said that particular area, people are tough nuts, right? I mean, but when we sat, almost everybody, 20 people, 14 people spoke up. They all said, Dekho, 20-25% 20-25% to hai. But you only gave me half acre. I have 5 acres. How are you going to give me for 5 acres, right? Let's talk about it. So that was very encouraging, coming from farmers. So the role that Heartfulness is playing at this time is more of a system integrator, right? We are no agricultural experts, right? But we're working with Central Institute of Cotton Research. We're working with ICAR, on research. Okay, we have set up horticulture as a carbon credit agency. Okay, and we can generate and sell carbon credits. We're working with execution partners, including Samanati. I mean, I work part time as an innovation lead in Samanati, and they have access to about 6,000 odd farmer producer organizations, right? So scale access to farmers is there. Okay, research is there, but obviously grants, like, to help run, right? My last penultimate slide, the proposal I have is that if you can find the funds for it, I think we should run this, we should adopt 20 villages across 10 agroclimatic zones, which have all the top crops, like, I mean, across India, and run a 3-year trial or a 5-year trial, right? First do it with 100 farmers, then go to 200 farmers, go to 500 farmers, right? And this will kind of comprehensively, like, work on the matrix, the type of soil, the type of agroclimatic zone, the kind of crop, the farming practices, and so on. Once this data set is there and we have ICAR or the local agri university as a partner, I think there will be enough data points, okay, first to prove or disprove it. Okay, initial data may or may not, may be biased, I do not know. Okay, but if you're able to do it at scale, it seems to hold potential and promise. Then, like, if we get the results, I think that should drive the policy, okay, a recommendation itself, right? Because without the policy recommendation and implementation, this is not going to scale, right? So this is the last slide, right? I mean, so this is where we are. For me, the fascinating thing, a non-agri guy coming into this, right? What's really fascinating is biochar seems to hit multiple stones at one time, right? Because it sequesters carbon, it fights climate change. Water, there's going to be scarcity, it can work with lesser water, not just improving soil fertility, but permanent soil fertility. And it can be an entrepreneurship model on the low tech side, and it improves yield and income, right? So it's something that should be worth pursuing and seeing, like, kick the tires and really see, like, what it does.
Great. Thank you. It's
I have one
wonderful.
question.
Yes.
How do you make sure that the biomass which is used to make biochar is not contaminated?
So it's a good question. Okay. Now, first of all, which biomass to use? Okay, in high tech, you can use everything. In low tech, right now we use woody biomass, cotton and stuff like that, right? But first of all, the temperature at which biomass gets converted to biochar is somewhere between 600 to 850 degrees. Okay, so even bacteria, everything gets burnt. And yes, and if the temperature is low, there is something called polyaromatic hydrocarbon, PAC or something like that, right? It can be toxic, but that only happens if the temperature is lower at 250, 300 degrees. So the process, okay, ensures that the biomass should be dry, less than 20% moisture, and the temperature should hit a minimum of 650, 700 degrees Celsius, right? And if once these two are taken care, it's only a question of whether carbon is at 50% or 60 or 70. I mean, what effect that has on fertility, I don't know. But at that level, when you put in soil, it's already a game changer. So there's nothing toxic. And one thing we've seen with farmers, You give them a white powder, there's suspicion because उनको पता नहीं है इस पे क्या है. But in front of them, when they see biomass, like, being burnt, like, you get black substance, there is no question. I say, ये तो डाल ही देंगे sir. Okay, there's a openness to it, and I've not yet come across a farmer. They say, kitna paisa hai, like, how can I afford? That question is there. But nobody is questioning as to whether I will put it in soil, like, ispe kya hoga. That question has not come up till now.
But we have standards, like quality standards as per as international biochar initiatives are there. So even in European systems, so they have some standards. In India, they do those phytotoxicity tests.
Yes.
Then those heavy metal tests and all
Correct.
those contamination tests. So
Correct.
here you are
We do,
doing.
we do. We
Yeah,
have all
it's
those
the same
standards.
standards
Yes,
you are following.
Yes. We use, because when we are a carbon agency, we are required to use those standard labs and measure it. So we follow the same standard protocol. Yeah.
I think physical and economic, these are the two parts of the game. I have one little question before I invite Sunil ji. Biochar cannot be used in isolation. It has to be combined with Jivamrit and manure, right? Do we have a control group where we are applying only Jivamrit without biochar? And then compare Jivamrit with biochar.
Yes.
Right? Reason being, I'll give you the policy problem.
Yeah.
5 years back, Finance Minister announced zero budget natural farming. Vash Palekar, you would know, of course. And everywhere, oh, Jiva Amrit, this, that. So we put one of our senior researchers with him that एक हफ्ता 24 घंटे इसके साथ रहना है, सोना भी उसके कमरे में है, और देखो क्या कर रहा है. सुभाष पालेकर के गांव में उसका भाई भी अडॉप्ट नहीं करता. ठीक है. Farmers, scientific community did not accept that directly. Modipuram ICR Institute did for 2 years that Jiva Amrit and natural farming, exactly the same way he had prescribed, and they experimented on wheat and rice. The productivity went down by 50% and 29%. 50% and 29%. So the entire ICR community rejected that. It is all bakwas. I published a paper with NABARD on that. And I didn't believe, I went to the farmers who were adopting that. वो जीवामृत, वो सारा process मैंने देखा 4 तरह का जो. Now, none was growing wheat or rice. They were all horticulture crops basically. राजस्थान में गया, दूसरी जगह गया. वो ऐसे घुमाना है, ये उसके अपने प्रोटोकॉल्स हैं. ठीक है,
ड्रम में बनाते हैं.
अब ये हो गया कि ये जीरो बजट तो नहीं है, इसमें बेसन तो लाना पड़ेगा, ये भी लाना पड़ेगा, वो लेबर प्रॉब्लम, ये सारा इकट्ठा कौन करेगा. तो इट्स ओनली सारे विलेज में 5 आदमी मुश्किल से अडॉप्ट कर रहे हैं. ओके. सो देन वी टॉक टू द गवर्नमेंट. तो भैया ये national policy when you are making, you cannot afford decrease of farmer. Whatever he wants to do, he should have the freedom. उसकी niche market उसको मिल रही है, उसकी economics ठीक हो रही है, चलने दो. Organic करे, non-organic. But as a national policy, if my wheat and rice productivity drops by 50% and 29%, it's a non-starter. फिर उन्होंने कहा अच्छा ये जीरो बजट नहीं है नेचुरल फार्मिंग. अब वो उसका 2000 करोड़ रुपए की एक पॉलिसी शुरू कर दी. मोदी जी जब भी उनसे मुलाकात होती है, अरे वो गुजरात के गवर्नर से जरूर मिलिए, वो आपको बताएंगे कैसे करना है, कुरुक्षेत्र में जाइए. सब कर लिया. वो विजय कुमार आपको पता है, उसका अपना. Question is, when you want to scale it up, ICAR community, the scientific community, did not buy that. Majority, I would say, 80%, 90% say that it's all humble. हम नेचुरल फार्मिंग ही करते थे 60s में और मर रहे थे. we were ship to mouth economy.
Yep.
So this fad that is coming back, ये लगाओ वो लगाओ और इतना गोबर कहाँ है, पहले उसका collection करना. So I saw personally there are some pluses, but scaling up is still out of reach. That's what I found. At the policy level, the scientific community has not bought that. So first biggest challenge is convincing the state agriculture universities क्योंकि उनके बिना कैसे scaling up करोगे? Whether there is interaction on that front. And that is a dilemma we are living in. Biochar plus Jivamrit. Right, that's your Jivamrit we have tested and we have written a paper on that.
Correct.
I'll share with you on that, and we have spent quite some time on that.
Yes.
But national policy, at least for basic staples, where the largest area is, that was a non-starter.
Yep.
And most of the scientists of ICR, including former DGs. So how do we convince the scientific community?
Yep.
All these results have to be open,
Right.
right?
Absolutely.
And then compared to chemical fertilizers, how do we go when, especially when you're giving literally free urea, 85% subsidy on urea? How do we, anyway, that policy thing will
I
come.
have two thoughts to share.
Mhm.
One, okay, we work extensively with ICAR. I've met the three DDGs, I've met the DG. I made a present. There was a ICAR ran a vice chancellor's meeting in Kana Shantivanam for 3 days, and I presented biochar to about 54 vice chancellors, right? And there was a nano urea presentation before me, and there was one other new technology presentation after me, and both of them got tulped. Okay, whereas in this, there was really a lot of positive response from ICAR. Okay, and I've also presented recently on carbon credits to about 200 people, scientists and vice chancellors from all ICAR institutes, because the DDG had facilitated it. A very positive reception. Now, what I also find is at least 20 to 25 ICAR universities. Some of them are crop science universities, some of them are arid or whatever, there are at least 20 to 30 biochar research labs and work that's going on. But from my limited and non-academic perspective, I think they're all digging very deep in one specific area, and there's no integration of a larger forum or panel in which they're all working together, right? And so this is required. That's one, right? The second thing is Jivamrut is only a beginning because I'm a baby, I've been working in this for 2 years, right? But when the protocol is done, and this is where I want to work with ICAR, okay? When the protocol is done, it will not be Jivamrut, right? It possibly is like for which soil, for which crop, what microbial solution needs to be put, and it can be a biofertilizer because that increases soil biology. So that is second thing. The third thing is, for me, okay, I just see promise and potential. And what I'm asking is not for policy or adoption, right? What I'm asking is, hey, let's pursue this. Let's actually implement it because the 10, 20 village adoption that I'm talking about, it's going to take money, it's going to take research, right? All I'm suggesting is we should move forward to the step where we kick the tires and see if this is for real, right? And make a policy recommendation based on the outcomes of this kind of research project.
Oh, that's great. I think let's hear him. I'll get back to that biofertilizers and
Sure.
other things
Sure.
because that's where policy contradicts many of the other innovative products. The policy wants reasonably quick results. And that's how this entire fertilizer, policy, which is one major distortion. We are trying to check with the government how
Talk about, how it probably something can be done within the already existing
There are
policies.
so
There are
many
some
this-
incentives for, for organic manure and city compost, etc. Whether that can fit, that's an incentive.
So let's get back to that.
Yeah.
So,
So thank you very much for giving this platform, but I think most of the point.
पहले दिखा तो दो ये खाने की चीज तो नहीं है ना?
No, sorry. So this is a biochar we made from paddy straw, pure paddy straw on a mechanized system.
Yeah.
So you can see that this has more energy value also, and also the agriculture biochar
Is
application.
this
So
high tech? We can call it high tech.
yeah, it's a high-tech kind of a device to make biochar. So can I put my slides? Yeah.
I
So a lot
visited
of,
farm. Sorry,
yeah,
go
sorry,
ahead.
sorry.
No,
Okay.
go ahead.
No, please, please. Yeah.
There's mycorrhiza.
Mm.
I remember Alok, if you know him, it took me 20 years back into the farms. Mycorrhiza revolution कर देंगे ये कर देंगे वही का वही टिका हुआ है कह रहे लोगों ने
No, sir, it has moved on. Many companies, yeah.
चलिए
वो fertilizer के scale पे नहीं है, if you are comparing it with the fertilizer.
So, first of all, thank you very much for hosting this brainstorming session and inviting me for. So our entry to this topic is largely from the we work with on the crop residue burning issues in many states, and the primary focus is to or energy application. That's our entry to this subject. And as you know that biomass under different ministries, uh, solid, liquid, and gaseous form. There are a lot of demand government has created through various schemes, and some of the prominent schemes are Samarth scheme, which is talking about co-firing in thermal power station to 5 to 7%. Then there is program called STAT, which is under Ministry of Petroleum and Natural Gas. They talk about CBG, the compressed biogas, 2G ethanol, all those kind of a liquid and gaseous form. And there is a huge mandate in all these things. But when we work with communities in any of these solid, liquid, and gaseous fuel, there are missing link. And that missing link is we are not talking about holistically. We are always talking about extracting out of the system. So when you talk to community, we see a lot of unmet energy demand in the rural areas, but nobody talks about that in form of cooking energy, for example. And so we try to integrate those gap areas, which are gaps in the whole value chain, and try to integrate community in this activity. So the trust building is important. And in one of these area, the biochar become equally important. As we know that biochar only for soil may not be a sustainable business entity independent. So it has to be find an application in energy application also. So that is how we are trying to look at decentralized biochar production application in rural areas with communities which we are working on. So those are so some of the I think some duplication what you have already learned. The biochar is a stable carbon enriched substance produced from biogenic feedstock material, woody biomass or uh, crop residue thing through thermal treatment with no or low oxygen atmosphere. That is important because all other forms, if you put too much of oxygen, then it's more of a traditional. You talk about that the soft charcoal or stable charcoal. So those are the principle that we have to use no oxygen or very limited oxygen. So that's where the device or innovation come into the picture. So it improves waste management by recycling organic material into the soil and pyrolysis for this is what we have discussed. So some of the biochar for agriculture, the critical there are many, but high water holding capacity as described by Shriram. Maintain soil pH is talked about. Pathogen control, improve soil fertility are some of the factors which we have talked about. Now look at from biochar production process perspective. So there are the 4 or 5 buckets are there. One is the biomass, which is a seasonal availability, need to be collect and store. So supply chain become essential for a biochar unit to be get as a business entity to be recognized as a business entity there. So biomass collection in form of agriculture residue or any other biomass to be gathered from this thing. That's a huge challenge in terms of working capital requirement, in terms of storage, in terms of everything, whatever is required. Then the first thing is because the drying of biomass in terms of bringing down to the reasonable level of 15% or 20% before you feed into the energy system to convert that into this. Otherwise, a lot of energy will be required to remove that moisture. So efficiency will be limited and a lot of energy input will be required. The third bucket is basically the biochar production, where with no oxygen or limited oxygen mechanism, you produce this biochar of high quality in terms of its energy output as well as the other parameter which is required. And then, of course, for biochar for agriculture, the distribution to farmers, how to create a market in a real situation, whether it's local market or the other markets we are talking about. There are few technological pathway we are talking about here. The first one is the Conti kind of the traditional way of making, which is a low tack with limited, I would say, capital requirement. You can produce biochar, which can be applied. And the cases you have just seen, the case studies and in the previous presentation. The other two are basically the gasifier, the middle one, sorry. The middle one, the gasifier, which is basically you do a low oxygen conversion process. Conversion efficiency is very high, and all the emissions which are produced during the volatiles which are released is burnt in the system because they are in-house itself, and you produce about 30-40% biochar in the process, and syngas can be used for either heating application or for power generation application as per the scale of the requirement. So it's a very efficient way of to produce biochar, and most of the energy which is there in the biomass can be taken out in form of syngas and biochar. Now we are talking about mobile biomass reactors. There are few models which are there. You can take it to the field and which convert this biomass into charcoal, and then you collect it and store it wherever this biomass is available. So mobile based units which can go deeper into the where biomass is available and collect that biomass. So the transportation of raw biomass is avoided in this case. So the cost reduction is possible with this innovation. So these are the gasifier based thing is more stationary. It has to be at a decentralized level at a one particular location, whereas the other one is, as you can see, the kiln can be taken up to the deeper into the villages. We have invented this auger based torrefier. We call it a torrefier, which operates because there are a lot of demand of torrefied biomass in thermal power station. And torrefication and biochar, the only difference is the temperature of process. So torrefication of biomass is done at 250 to 300 degrees Celsius. It has very similar properties as coal we use in thermal power station. And so there's a lot of demand of that biomass or the torrefied form of biomass in thermal power station, and in all states basically. And the same unit can operate at a higher temperature, say about 550 plus 650 degree, and produce biochar in form of. So we tested this. I would say it's still decentralized 1 to 2 ton charcoal production on a per shift basis. And we tried paddy straw, sugarcane thrash, and corn cob, which are most commonly available in rural areas without much use as a feed material, and operated this system, and trying to scale up this process for real market scenario perspective. our application is not limited to agriculture per se. We are also looking the char or clarified form of biomass in energy and power application. As I told you that a lot of demand in thermal power station. Of course, for industries, for chemical processes, gas and water purification system, where these kind of a basic material is required for filtration and other thing also. The big industry which is unfolding is the steel industry, where decarbonization of steel, there are very limited options, and biochar is one such solution. We are talking about particularly, for example, bamboo charcoal, which is very highly energy intense feed material for steel application. So some experiment which are happening in Tata Steel, Jindal, for example, with these kind of products also. So biochar is has multiple applications, agriculture and then energy, thermal power station, and so it can transform energy and non-energy applications in the country in true sense. Now, as we have seen that the economics of biochar, this is based on our this thing. So for 1 kg of charcoal, 3 kg of feed material is required. And we believe, based on our assessment of collection and different type of biomass which we are collecting at different location, this is the latest price. The 3,000 rupees per kg is the price.
3,000 per kg?
30,000 rupees per ton. Sorry, 3 kg. 3,000 rupees per ton. Considering, so 9 rupees is the raw material cost. Electricity and labor is come to about 2 rupees per kg of output. Maintenance is 0.5 and other spares kind of a thing point. So 12 and a half rupees is the real cost of biochar based on the current technology and the scale we have. So as if it is more mobile system, we get into inside, so the cost of biomass can be reduced. Then you can bring down this 12 rupees to say 8 rupees, what the experiment you are doing. So that possibility may be there in terms of collection efficiency, in terms of reducing the cost of collection itself. Now the key challenge, the limitation, what you have talked about is no proven business model on ground for this unit to get sustained in terms of establishing no proven demand as of now. It's all pilot. Then market demand is limited because of the limited awareness and demand of biochar. It's a very beginning stage as such for agriculture as such. Feedstock availability, there is an inconsistent supply and quality of biomass on season to season and time of the year also. Financial viability, uncertainty, profitability, and high investment, particularly in the mechanized form of biochar production facility, where the initial investment is a challenge. Then there are technological complexity, difficult to maintain optimal conditions without expertise. So there's a skill part of that. So if you have to scale up this system, where are the operator, where are the skills, if the unit can be set up, so that required a specialized, and that's the role of possibly institutions like yours or skill council green job has to come in and all that kind of a thing. Then only the technology can work. Limited, so as we see, the biochar is only the carrier. All other inputs has to come in terms of plant growth perspective. So pilot demonstration with business model is essential for increased biochar and market success. With that as an objective, we are, I just keep, so we are trying to look at our approach is innovative and integrated approach involving local communities for scaling up of application with these as a mechanism. And carbon credit incentives are very important element in this. And trying to bring some government subsidies which are critical for setting up these facilities on ground, which is not there exist today. We are trying to work with again in state of Madhya Pradesh in Barwani districts. We have recently conducted some awareness and sensitization program in Barwani with Aparajita Mahila Sangh to set up this 2 ton per day decentralized biochar production facility in this setup. Engage them with biochar and some of the unmet demand in their rural homes. That also was integral part of this program.
This 2 TPD is biochar or biomass?
Biochar. 2 TPD output.
How many hours are we talking?
8 hours, 8 to 10 hours kind of a scale per hours. So we are trying to mobilize some CSR funding for this to happen there. So through this Mahila Sangh, we have put up some proposal which are under advanced stage as of now.
Those who are dependent on CSR, they should know
Yeah.
what sort of pictures they need to see.
Yeah. So coming back to just a few why so we are primarily in different geography. We are working on biomass aggregation and collection from fuel perspective, pallet perspective, and these are some of the like we provide skills, we provide working capital to local communities. Like in these case, this is a lantana where youth has given some tools to handle to collect this lantana, for example, and this is in Uttarakhand, the one you see on the top picture. And then this is pine needle, again in Uttarakhand, where we work with the local forest department there. Then sugarcane, some paddy straw. In Chhatarpur, we do a lot of collection of Sisme waste, for example, bamboo, for example. So variety of biomass which is available across season, which can be used for biochar or energy application. Those are.
So just one question, just I'd like to interrupt you. Like you're producing biochar and at that high temperature, there will be a requirement of lot of energy. So you're giving which kind of an energy?
Net energy care.
Yeah.
Yeah. So
Energy balance.
so energy balance is the whatever the volatiles are there in the biomass. So fixed carbon you are taking in the form of biochar. There is a lot of the energy in the volatile, which is a gaseous form. And that when you heat up that biomass, it is self-sustaining system inside. So the heat which is required is basically coming from the volatiles in the system.
So it's a circular.
It's just circular.
economy.
It is nothing
So it's
external.
basically
Yes.
just giving the
Yeah.
energy and you are giving the biochar, so whatever.
It's a fuel.
It's a fuel by itself, so you're
So
just
that's
burning
the
it.
same fuel you use it
So
for
there
heating
are,
it up.
if you look at the biomass, there are fractions of carbon which we required in the end product, the biochar, for example. The volatiles, which is almost about 60%. And
Okay.
that volatiles are basically like converted into syngas and burn in form of. So that is providing the internal heat to sustain the operation.
Just first time
Yeah.
you're giving the
Yes.
energy and then it is self-sustaining.
So some of our.
Same for the low cost one also.
Okay.
Yeah.
You're directly firing it. Here, there might be indirect firing, right? But the syngases, carbon monoxide, methane, hydrogen, they're all combustible.
So self-sustaining
So
system.
what you are saying is that those gases are escaping or you?
No,
are
no,
They
internally.
recycling it
Yeah.
back
Has to
to the
recycle
fuel.
it
Yeah,
back.
as a fuel. Because you required.
They are more energy conscious point of view.
Yeah, that's why.
Yeah. So we are, as of now, because we are supplying it to this biomass pellet, as I told you, the NTPC Khargaon, NTPC Gadarwara, NTPC Vindhyachal, Singrauli, Dadri, which is a big program under the Samarth program, which is both torrefied and non-torrefied biomass. And there is a huge demand, which is, so the challenge for the policy perspective is uh, how much biomass for energy, how much biomass for biochar. So all those model has to come in terms of sustainable model you can see. Otherwise, always X2, X2 and in situ kind of that tussle will keep happening in this case. Biochar as a medium can meet both the requirements. in true sense, as we are saying. So this,
Energy or food?
No, but what's the surplus biomass available? I mean,
Yeah,
600, 700 million tons is fine.
yeah,
But out of that, it's how much is available?
230 million ton, as per the latest figure by ASCII, by MNRE, has been published. It's a state level inventory of thing is there.
So from 230 million tons,
Yeah.
how much?
230 million tons in Madhya Pradesh.
No,
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 the
all
surplus
India,
for
pan
all
India,
over
pan
India.
India, pan
Pan
India,
India.
pan India, 230 million.
Biomass.
Surplus biomass.
Surplus, because it's around 700 million tons.
750, they talk about
The
the total biomass.
availability, yeah.
And most of that is used either for feed, fodder, and other energy application. Whatever which is being surplus in form of which farmer is burning on the field is close to about 230 to 250 million tons. As
So
one
you
third.
say, yeah, so you say this is sufficient both for the bioenergy as well as for the.
I will
biochar?
tell you for 5% blending target, the requirement is 50 million ton. 5% blending target
No, now
for,
it is 20%.
that's not, and,
But blending target, ethanol,
Ethanol.
now it
no,
has
no, not ethanol, gas. This is
This is-
co-firing.
co-firing
I'm
target.
talking, co-firing. I'm talking about one target, which is in thermal power station.
Okay,
That is 50 million ton.
okay.
Then you have 2G ethanol,
Hmm.
you have target for CBG, that's separate.
So we have competition for all these
Right.
biomasses. And then we also have residue incorporation, because in biochar, you are also mentioning that it's this inert carbon. Rest of the nutrients, they are getting lost. But when we are incorporating, so there is a issue with the carbon, it will be lost, but the nutrients will be saved. So
Yes.
from the soil perspective, which is better?
I think that's a question you have to come with a model.
Yes.
Check.
Yeah.
But man, this is
Just asking,
done.
last
No, no,
if you're coming from the soil, if we are incorporating.
Yeah, please.
Okay. Now,
Like
Reena,
like you mentioned that the application in steel industry can also be there in biochar. So there is a thing called green steel, which is quite popular these days. So can we, like, when we talk about the electrical arc furnace that we are used to put in the green steel making, so can we like bring in biochar somewhere in it because of the foamy substance that the carbon is inputted into the uh, electrical arc furnace when we
Instead of coke, you use the biochar for reduction of iron ore. What steel are doing, they are reducing the iron ore to iron, to metal, where carbon is required. So they are using coke. Coke is made from coal, which is called coking coal, which we don't have. Plus it is again emitting carbon dioxide, GHG emission. So they are working on technologies where GHG emission can be reduced. So what he's saying is that biochar can be used to substitute to coking coal in the steel plant, blast furnaces.
But let me just let me tell you that our biomass or crop residue is more decentralized. It's a dispersed resource. We have landholding
Right.
are small. So lot of national programs currently which is on, they are talking about refinery scale aggregation, which is not happening and which will not happen economically or sustainably.
It's like solar energy,
Yeah.
wind energy, it's a
So
very
the
dispersed.
model
dilute.
has to come in from the decentralized mechanism also. So biochar, which is more decentralized application also, and also the technology scale also. So I think that story can be a good success compared to a lot of aggregation and coming to more realization can happen in steel, for example, for biochar. So 25 rupees, but volumes are huge. You just can't produce those volumes at one location.
Exactly.
So the trade is basically that.
Potential is
Yeah.
low because of the availability of one place. Yeah.
actually good. Thanks a lot. Reena, you would like to give your comments, observations
Yeah, because
we have to finish off maximum within half an hour.
as
I
you
mean,
mentioned that
you take 5-7 minutes or
Yeah.
you can take 5-7.
So if
Yeah.
we can evaluate biochar on the basis of like soil, water, air, and the biodiversity perspective, from that perspective, what I was saying that residue incorporation is one technology, and now we are coming up with the biochar technology. Both the technologies are environmental friendly. But in residue incorporation, carbon is not getting fixed. What happens when the plants, they are doing the photosynthesis, they are storing the carbon, but once they are getting decomposed, that carbon is released into the atmosphere. But if we are incorporating those residue inside the soil, the nutrient properties that the residue is having, like nitrogen, phosphorus, potassium, then sulfur, and other micronutrients, it is giving back to the soil. So in that sense, yes, the nutrient value of the soil has increased. But when we are talking about the biochar, the carbon is not getting lost. So at least 85 to 95% when we are doing the residue incorporation, it will go to the carbon dioxide. Here, at least I think the 50% of the carbon, it will be sequestered inside. 75%, okay, depending upon the technology. So we are able to sequester the soil carbon. So that is a positive point. But what about the other nutrients? We will not be getting that nutrients. That is one point that I would like to flag. And secondly, how much percentage of soil organic carbon improvement has happened? Because with case of biochar, it's the application of the carbon. So do we have any such results? Like our soils are very less deficient in the soil organic carbon contents. With this application, like if the soil carbon was 0.35% or 0.5%, are we able to, can we say that, okay, from 0.5%, if we are applying biochar at that particular application rate, wherever it is 4 tons, 8 tons, whatever it is, can we say that with this application, it will improve from 0.5 to 1%? Can we place such kind of a target for our Indians? Or is it a possibility or it's not a possibility or it's too early to answer this? This is my question with respect to the soil part. Water, both the presentations have covered like it is able to retain some water and you have shown very good amount of data. And I understand, I'm assuming right now with those afforestation trials, which you have mentioned, like from 1200 feet, it has moved to 300 to 400 feet. Is it, they have included biochar. So from that, yes, it is ticking that particular box. It is able to retain and it is able to absorb the water. So it's very good for the water retention point of view. And with respect to the carbon air, if we see both the presentations, so my analysis is that if we have somewhere around 200 million tons of carbon, and even if 30% of that particular thing they are getting converted into biochar, so we will have some estimates of our soil carbon content, and we can safely say that some numbers are already there in the literature that this much amount of sequestration we can happen. That is one point. Another point is if we are not burning our residues, we are also saving the methane emissions, nitrous oxide emissions, and also the carbon dioxide emissions. And based on that, we are able to save those emissions also. So that is the reason these residues, they have been, this biochar technology have been introduced as an offset mechanism in both agriculture as well as the waste sector. So it is definitely, it has the potential to hold the carbon credit things for the farmers and for the country as a whole. And with respect to biodiversity, yes, it improves.
We
So
need to
from,
monetize
we have
that
to
and have
monetize.
to create incentive structures.
I was wondering why that started in Haryana and or Punjab, where there could be a lot of attention and a lot of people coming to help. I think they have, as pointed out by market, feedstock, viability, technology. I think the controlling factor here, or the most slow, what we call it in chemistry, the slowest step determines the overall rate of reaction. In my opinion, it's not so much of a market. And I don't think people will be skeptical for applying biochar to the farmers. It's more of a production or collection of biomass, which remains a basic, very, very, cost aspect. And because every feedstock will generate a different biomass with every conditions. You pointed out two different conditions, one for generating fuel at lower temperature, and for higher temperature, you generating biochar for agriculture. It more becomes more stable. Production aspect, when you do the, I don't know, you said you are recycling the gases, but it's a difficult part at the cottage level or a smaller level. I don't think you are doing that because they are being let off. And then you generate some tar also. I don't know what you do with that tar. Because then you generate liquid, you generate gas, and you generate the solid. That's when you do the energy balance, which you are talking about. So if you sort out the production kind of a thing, then application is again is not a one treatment for all. That one thing, if you have to try like biofertilizers in that particular area from which biomass and which biomass properties, which will depend on the process you adopt, you have to match that. You have to prove that, and then you can probably sell it. Financial viability, I think, if what you have shown, the carbon credits can be taken, and I think government can be convinced at least for few thousand rupees a ton subsidy, which they are giving already for this, uh, this bioslurry now, and there are specification in FCO and organic manure also. 15. They say, of course, right now it's a 1,500 rupees a ton, and for city compost. That's another area where that this waste should be to wealth.
That is being Govardhan scheme.
Gobar gas plant, this slurry as well as
Yeah.
dry, they are giving 1,500 rupees, which probably they can be convinced to increase. So I think financial viability can be established even at the pilot scale. Probably the government should be able to extend that kind of a thing. So main thing remains the availability of biomass, what type of biomass, and the optimization of production, as well as matching the soil needs. Of course, you also talked about excess use. Availability is poor, so excess use may not be there, but excess use works in reverse. What they say is that it gives the mobility to the nutrients while you are applying through, let's say, chemical fertilizers. It makes them more available to the, because their mobility or transportation becomes easier. And once you apply in excess, then they start absorbing them and fixing them, which are not available to the plant. And so, but I don't think we will cross that limit that we are applying every year. You said you apply 2 tons per annum. I think that optimization has to be done 1 tons per annum for 4 consequent years, and then you stop it another 4 years, something like that. It has to be done. So the controlling or slowest step in this one is, in my opinion, the collection of biomass and reducing the quality biomass which is suitable for agriculture. Thank you.
Thank you very much. I see some people also online. Would anyone like to ask any question to our main speakers? Any observations, comments? Sulakshna, Suvangi, Harsh. Are you there or just kept it on and then disappeared? All right. Anyone else here? Yes, please. Go ahead.
So you were mentioning that with the subsequent applications, there should be some impact on nutrient absorption. So do we have any study where we can say that, a chemical fertilizer demand or requirement reduces with application of biochar?
I can say that the fertilizer use efficiency increases, right? There are papers, which there are a lot of published papers. So there are almost 200,000 published papers on biochar. The only thing is, the context with soil, how much application, what biomass, a lot of variations which you're not aware, right? But at least two broad things I can say is that, one recommendation, one school of thought is that first year, second year, don't touch anything because you don't want to experiment with farmers, right? But in the third year, you reduce fertilizer use by 25%, and in the fourth year, you can reduce fertilizer use by 50%. And that is something like that some papers talk about, right? In there are people, okay, other researchers who said like in even the second year they reduced it by 25%, and they found that the yield, okay, when you use 100% fertilizer and 75% fertilizer were identical, right? Because all the leaching that happens, see, a couple of things, right? One is the leaching that happens in the soil. First of all, that is absorbed by the biochar because it's porous. And when the water is given through capillary effect, this kind of becomes available, right? So it's like instead of feeding your baby once a week, you're feeding it once a day, okay, or whatever, continuous feeding over a period of time, right? So the theory is definitely that fertilizer use efficiency. How much, how can we reduce, whether we do it in controlled trials, farmers, it's a little sensitive because we can't play around, but that's where these studies are important.
There's a need for study. What is saying the nutrient use efficiency? When
Yeah.
you are working with ICAR,
Yes.
probably nutrient use efficiency to start with nitrogen itself.
Yeah.
One can do some scientific experiments.
I have a question, sir. Taking the case of ICAR, what specific role can Krishi Vigyan Kendras play in giving fillip to this particular thing? This is one question I had. And secondly, as vice chancellors of agri universities, state or central, what kind of a specific next step can we encourage them to take in this regard?
See, Dr. Lali mentioned, you need a credibility. Whether it's a state agriculture university or one of the ICAR excellent, research institute, you join hands with them. One study is nutrient use efficiency, other is water use efficiency. So these experiments can be laid out, and once they are there, then you have the credibility for those results, rather than just because this is fine. Those people who have the missionary approach, they say if water will be reduced subsequently, this 50%, he said, he is saying, and these claims are sometimes scare people, and they say, okay, you come. If 50% application of the urea can be reduced in 2 years, so these things don't work. Finally, because the scientific community is not. Once you do join hands with this scientific community and do the experiment and prove that.
I can respond, but I'll get back to this question. Any other questions? Online or here? Online people can speak or no?
There, I guess.
Right. I think okay. Yeah, go ahead.
So you talked about three pathways, technological pathways. Do we have any estimates on energy emissions released from these pathways, and what is the efficiency rate in these three?
One is a traditional
Yeah.
system, which
Right.
is low tech
Village
and
level,
emissions may be higher in terms of from a carbon credit perspective, that may be low. On gasification and from
Net
uh,
emission.
gasification system, the overall energy balance is very positive of the overall energy system, because you are using all three systems, whether the syngas, biochar, and everything. So recovery is very high, say 90%. The energy form in terms of, and emissions are very low. On the mobile or the one which I have shown you, that which is no oxygen kind of a scenario. The net energy balance is slightly more in terms of with gasifier, but uh, I would say there are advantage disadvantage on both the system, because that is more static, that is more mobile system. So situation to situation you have to adopt it. Scale may be different. Like for example, what scale output biochar system you are looking. So choice of technology or pathway will be all dependent on the specific situation.
That's operating condition.
Yeah, operating conditions.
But when you say gasification with what?
Air.
Anyone else? Well, then let me thank our great speakers. We have learned a lot. Let me try to put two, three things together. And I get back to my framework of analysis. On the product side, how it is to be created, we have a huge so-called surplus or waste biomass in the system. Can we convert that waste into wealth? Right? And since if agriculture is our main concern, energy is your concern, but agriculture, since it is going to stay there for a long, long time, and interestingly, this is not a new product that we have innovated today. It has been there since Brazilians for thousands of years. So the local wisdom is getting back into, but at that time the scales were small. Local communities could do it. And now the need and the scale is much bigger. So the challenge of creating a supply chain which is efficient and what would be the pricing of it, what would be the economics of it, that's a major, major challenge. But I think if we have to change the policy, and that's where scaling up comes in. Carbon, we have been writing, we just brought out a publication, Reena, on the low carbon agriculture. And the World Food Laureate, Ratan Lal, has been saying that soil organic carbon should be about 1.5 to 2%. Our 60% of our soils are less than 0.5. So that's why I said they are in ICU. So one critical thing when you are putting this carbon literally into the soil, by how much what Reena was saying, after a year or 2 years, we need to measure at what is the level of carbon in this now. And what are the benefits of that carbon in terms of productivity? Because ultimately that has to be translated into not just productivity in terms of quintals, but I would say the nutritive value of the produce. Do we create better nutrition in our food? Because if they are able to absorb other minerals, then our crops should be more nutritious. Today they have become deficient in zinc, wheat, and rice, and therefore that is causing stunting amongst children. Right? So when more carbon is there, their basic job is to create the bacterial activity in the system down below and absorb all those nutrients, and therefore they are translated into nutritious food. And that nutritious food can help us improve the human nutrition. That's a challenge we have been struggling with, how to measure it. Okay, what we know, many people are saying, oh, one orange in 1960 is equal to 3 oranges today because the nutritive value is not there. And same thing in wheat and rice. The desi wheat and rice was much more nutritious, but when you want more through fertilization of chemicals, you can get more productivity, more grain, but the nutrition value has gone down. So how do we link up this? If we can somehow measure, even at a pilot level, that you will get better nutrition and that will help you improve the human nutrition, right? We are spending almost 2 lakh crores every year on this chemical fertilizers. 2 lakh crores. Now, this is an alternative development path, which is benign to nature, right? Our soils we call Mother Earth, but we are damaging Mother Earth like anything. So with that, can we improve the nutrition of soils and therefore the nutrition in our produce and human nutrition? Then we can make a case of repurposing what we say of our policies, which are Patient positive, planet positive. My only concern is productivity should not go down because I'm afraid of this so-called natural farming or zero budget natural farming, because we have studied that for 6, 8 months very closely. And 4 cycles that they did in Modipuram ICR Institute, after that they said, no, this cannot be a national policy. That's where the credibility of the system. If the ICR scientific community is not with you, that's the government body, that's the scientific body. Then the political master, here and there, some pilots can be fine. That is your passion. But passion in pursuit for perfection to change policies has to be quantified. And it should be open for any third party. And I'll tell you, Vijay Kumar, who has been doing a lot of work in that, and some secretary asked him, ask Ashok Gulati to evaluate this. No, I don't want him there. And I hear all sorts of stories. The Germans who had been funding GIZ. So there are wheels within wheels. Okay. So if you have to be, you are open for scrutiny, transparency basically, because there's no other way to earn trust. Trust is through transparency, and it should be open to anybody. Okay, come test, let's see. We are doing all this. I think that third party evaluation, this is why whatever CSR funds are invested, and I chair some of the CSR committee. दुनिया बदल दी हमने, ये कर दिया, वो कर दिया. Nobody buys that. जब मैं उस फील्ड में जाता हूँ, एक चेक डैम हमने इतने बना दिए. I don't want to name the company. इतने चेक डैम बना दिए, वहां गए पानी नहीं है. दिखाओ कहाँ चेक डैम तुम्हारा. एक जरा सी दीवार खड़ी कर दी है, चेक डैम बन गया जी. So there is a lot of greenwashing that's happening. Companies do it, NGOs do it. Okay? So both sides' credibility is very weak because 80% of NGOs are making good money. They call themselves non-profit. 50 दुकानें खुली हुई हैं. जहां से लोग जाके खोल देते हैं. NGO बन जाते हैं. This is all money-making exercise. Very few people, not more than 20% of NGOs are really committed for a cause. And that's giving. So I think for this trust building, transparency, and of course, communication has to be there. It's still not, you have read those things. We have been the whole of agriculture team here. We have almost 25 people here. And they are not very much tuned to this product and the policy. But fertilizer policy is the biggest elephant in the room. And because it is created at a scale, easiest to use, they just keep throwing it. And government is convinced that this is increasing production. That's why they are spending every year 2 lakh crores. आपको 2000 crore नहीं देंगे. So you have to convince. And that's, we may start at a state level, smaller. If Chief Minister of Madhya Pradesh is ready to listen, create that, okay, the pictures that you showed, what it was and what it is now, and this is the transformation that can, but we need to measure some of those benefits. How much is the carbon now in the soil compared to what it was? How much is the productivity? And how much is the retention water? All these things. I think if we can do that, then our benefit here, because we continuously interact with the policy makers, and we are supposed to be a policy think tank. I remember 20 years back when mycorrhiza, she's saying, oh, it is spreading. Good compared to where fertilizer subsidy is. And I remember at that time I had a meeting with the finance minister that you are spending so much money here is mycorrhiza. Why don't you give? They need good, solid evidence. Scientific community may gungan or my nano fertilizer. In this very room, we had IFCO people and Coromandel people. We had a similar type of, round table. Those who have come up with, they say we are even exporting all this nano urea. The scientific community, ICR, and the farmers, we went in farmers, you were there.
Every state.
जबरदस्ती ठोक रहे हैं हमें. Nobody in Punjab wanted to buy that. जबरदस्ती ठोक रहे हैं क्योंकि वो यूरिया नहीं देंगे बैग जब तक ये नहीं खरीदोगे.
इसमें स्पेसिफिक एग्जांपल जो साइंटिस्ट ने दी है नैनो यूरिया के लिए, दैट आप नैनो यूरिया स्प्रे कर रहे हैं. हैव यू स्प्रेड द ऑर्डिनरी यूरिया सॉल्यूशन? यू हैव टू कंपेयर same application technology.
He has spent his lifetime literally in fertilizer
So you have to
industry.
compare. So they are
He's not
questioning
convinced.
that. But what it derives from here is that instead of, we are not talking of here organic farming or natural farming. We are talking of the biochar, how it can reduce the need for chemical fertilizer. That's where this nutrient use efficiency, carbon content of soil, and farmers can see without affecting productivity that they have
That's it.
reduced the 10%. If you can reduce 5% of urea application in 10% of the areas in the country, it's a huge
Because this is the biggest.
huge money.
Think of what government, this was introduced in 1977. We were still struggling on grains. खाने को नहीं था. This has continued since
77.
77 में ही तो retention price scheme शुरू हुई थी ना.
It started actually first oil crisis, 74,
73, 74.
73.
लेकिन जो subsidization तगड़ा, anyway, 70s में start हुआ. आज तक चल रहा है because they wanted and they still feel by applying this chemical fertilizers, they can get quick results in terms of higher productivity. Nutrition बाद में बात है, पहले पेट भरे. Now, if we have to change this policy, because the money has to be repurposed for sustainability, because sustainability now, climate change तो एक खतरा है, but this is not climate change. This is changing the very structure of Mother Earth, soil, water. Now, if we can demonstrate that we can make our Mother Earth healthier, which will provide you healthier food, which will give you better health, then I think we have succeeded. Otherwise, these will remain, I'm afraid, pilots. And it has to be evaluated by third party, especially the scientists. That's where role of KVK. But at least first you take the state agriculture university in confidence. Because unless they put it under their practice of package of practices, that's why I was saying product and practices. Unless they recommend, KVK cannot say anything. And they are the extension of. So the package of practice at the state agriculture university has to say that our soils have become deficient in carbon and this is the way to do it and therefore this much money. And maybe some little incentive, some subsidy element the state government can start on. Or put up a block, okay, CSR funding एक block के लिए मिल जाए. So I think that's where we can then, so package of practices. And the biggest challenge is Punjab, Haryana. क्या गदर हो रहा है? Ecological disaster is taking place.
Yeah, the state universities, they do those validation trials. If you're giving them the product, so they test it in their
Yeah.
own fields.
I mean, at the first when I came this January to India, we went to PAU. PAU, because वहाँ तो सब कुछ है, if that can get solved, as you said.
That's it.
However, what you can probably say it better, what that two professors, what they were saying was that we have a benchmark of reputation and quality to uphold and standards to uphold. If we say, yes, this is
Yeah.
a go,
Yeah.
it means we are standing behind it.
Yes.
And then suppose something happens,
Uh-huh.
and or there is even in his case, he was saying that how much is leaking out, how much is being,
Yeah.
what are the emissions?
Yeah.
Like till that is watertight,
Yeah.
we can't really recommend. But they've been working for 15, 20 years. 15 years, they've adopted a village, a few
Mhm.
villages where
Mhm.
they're trying to do this.
Mhm.
And they're saying the problem is whatever technology we use, it produces more ash than biochar. So sab kuch ash ho jata. He showed me a picture
So
that
that's where
this is my student who's trying this technology.
this is
ash.
this
So
is where
because
we
of
need to
straw,
work very
right?
closely with the state agriculture university first thing. Because KVK will not do anything unless the state agriculture university puts a stamp on it.
So they're very interested. Like you were asking, why not Haryana and Punjab? Because of what they grow. And so then they're thinking, can we mix it with other things? I mean, you also went.
Yeah.
And it's a process. And so what the hope was that they will partner, they'll
Yeah.
become partners and they will try things
Yes.
there
Yeah.
in that domain, in that terrain, and see what is the optimal mix of both biomass as well as technology.
There is another
Wouldn't there is one, is that Sulakshana? Would there be barriers preventing small and marginal farmers in Punjab from participating in biochar initiative? How can government incentives be redesigned to accommodate them? Small and also what kind of decentralized infrastructure, institutional support is needed to make this process accessible and economically viable for our small and marginal farmers? So the issue is small and marginal farmers, how can we?
They are coming. I mean, this professor said that they come every day.
Mhm.
And there are people with funding who come every day.
Mhm.
But they said, we don't have the technology. We
Mhm.
can't really stand behind it yet because our biomass is very tricky.
Yeah.
If we had bamboo, if we had cotton, if we had other things, it would not be the same.
What would be the investment required to run
correct.
method
Yeah.
which Mr. Sunil suggested?
So, for the gasification or the auger-based solution I described, uh, the for the 2 ton per day output, one shift basis, capital investment will be close to about 1 CR
2 ton of biochar.
of biochar. Yes.
Okay. So that means 6 tons of biomass.
It's competition at that level because people need it for feed, they need it for many other
Yeah.
things. Some people are allying with the forest department, but they also need some residue for their own crops. And I mean, but there are ways. It's not that it's impossible, but it's distributed, not centrally.
There is a lot of work, at least in Punjab side, and government has given a lot of money subsidy. And this energy, or this paddy straw, because paddy straw is a killer.
Yeah.
And, they need to convert that into
Pellets,
fuel, basically.
Yeah.
So a lot of companies have come up
Yeah.
for that. And government is giving some subsidy support to collect and do that. And same thing in the manure, gobar and all that. I think Chhattisgarh was the first state perhaps to announce 3 rupees kilo gobar kharidenge, something, all those things.
This time there will be one inspector.
Yeah.
For few villages,
Uh-huh.
so they don't burn it in the field.
Uh-huh.
अभी तो बहुत
Yeah.
ही ज़्यादा crisis kind of
Yeah.
a situation.
So Madhya Pradesh is a good state to start with.
Yeah.
वहाँ पे भी अच्छी खासी रेसिड्यू बर्निंग हो रही है
Yeah.
मध्य प्रदेश में.
First of all,
There are some single superphosphate manufacturers in that area.
Okay.
Near Sagar.
Okay, we need
Near
to
Chhatarpur
wind up.
and Sagar.
Last words from you.
No.
Yeah.
It's more a question. Okay. First of all, it's been very enriching. Okay. And I think the kind of questions you mentioned in terms of what kind of third-party validation research and actually back it with scientific data, not just about productivity, but about nutrition and what is the residual effect on soil and on climate, on the air, right? I think they're really, really valuable for me, right? But like mine, which is essentially a non-profit organization, right? So because we've tried it, we've seen it effect, and we care for social impact. Like, we've taken it based on whatever possibilities are there within our reach, like, to take it, right? And I will take it forward with whatever abilities are there. But the question I have for the larger community, okay, is that, okay, policymaking community is that, so is there, if there is a potential idea, okay, and if there's real potential that it could perhaps, like, even a probability of addressing the elephant in the room, right? How can we access support, financial, research, okay, and institutional support to actually run a completely validated, credible, third party validated, like, a study of some size and scale, like, which can actually be sufficient to recommend policy, right?
Yeah.
Because if you leave it to organizations like us, I don't see us going there. And we will keep trying, but then, like, it might be a thing that could have been done, like, but so how do we get that support to actually
That's
Yes,
interesting, because we work on policies. That's our strength, sitting in Delhi. Also, interaction takes place, and we are working on environmental issues, so that's one of our major areas. And we are likely to be picking up even more on the soil question. So given all this, we can study your thing more closely, what is happening.
Okay.
So you should be open and we will have 20 questions.
Yeah.
Right? And because then when we recommend something, it is our credibility also, like the scientists.
Totally. Totally.
So I think we need to study. You are into action.
Yes.
With a passion.
Yes.
Right?
Yes.
And you feel this is the way to go and transform.
Yes.
That's right. That's your commitment. Now, we come with 20 question marks.
Yeah.
Because we look at the same thing. There are 20 products, only 2 succeed. Right? So many, startups, 95% fail.
Totally.
Right? Revolution is by 1 or 2 or 3. Right? So the question is, if whatever you are doing, we'll visit. I can put 2 persons on the job.
Yeah.
And then look at that, get all the data, verify that, question, read the international literature, what it says, what is the science behind this, because converting that into biochar and all this. So full study has to be done.
Sure.
And whatever little resources we have, we can put on that. And if there is something more to be done, we can jointly think of writing a proposal. And there are people, if they feel there is a commitment and there is a good cause, CSR funding, one can get something. But we will go to the government when we are convinced that this is the science, these are the results, these are the pros, and these are the cons also. Everything is not rosy. There are challenges.
Completely.
Right?
Oh, yes.
So, and then you have to evaluate. Our expertise as on today is more into fertilizer subsidy. We have been studying, at least I have been studying for the last 35 years. He has spent his life. Right? So fertilizer subsidy, what is happening? Can we change some levers there? Because this is the biggest money that is going. Fertilizer subsidy is bigger than the entire budget of Ministry of Agriculture.
Yeah.
Okay.
Yes.
So this natural farming, 500 crores, 200 crores, 2000 crores are nothing compared to 2 lakh crores every year. So if we can influence that and say that you are not to spend anything extra, it is out of this, that because it will save you fertilizers, 10%, 20%, 15%.
Right.
But nano fertilizer was by compulsion being given to the farmers, and farmers were rejecting and block. You were there. I said, nothing doing, ये जबरदस्ती में ठोक रहे हैं, कुछ नहीं है, पता नहीं क्या पानी पिला रहे हैं उसको. So scientific community of ICR was not convinced. And then I had sitting even with the chairman of IFCO. And he said, no, Ashok, now we are not giving जबरदस्ती. वो तो प्राइम मिनिस्टर ने जबरदस्ती लगवा दिया कि अगर वो कटा चाहिए आपको, if you want the
Tagging.
bag of urea,
We call
then
it tagging.
tagging. So anything by force,
Yeah.
it will not succeed.
Mm.
The demand has to come from the benefits that they see. And for that, you have to pick up some lead farmers, little block, and convert what you are showing, that how you have converted this.
And I think given that there are ICAR connections already, some
Yeah,
scientists are
yeah, yeah.
involved.
Those
Maybe
could-
really bringing
We have the lead farmers. Okay, we have, we're working with 2 blocks of farmers in 2 states. Okay, it's fairly significant. Okay, we are connected to ICA, but I don't know if we are asking the right questions. I got a lot of very good questions and.
नहीं नहीं हम मध्य प्रदेश
So,
का ही करेंगे
मध्य
because
प्रदेश
शिवराज
करेंगे.
सिंह चौहान
Yes,
है
yes.
मध्य प्रदेश का.
Yes. No.
So we
And-
can reach him.
And from a principal perspective, right, while I'm passionate for this cause, I'm not wedded to this cause, right? And I also want to know, okay, I mean, I'm also sitting on the same side of the table, wanting to know, like, if this thing really works, then, like, we really have something on our hands. And I'm very much like, for 100% transfer from my side. Okay. So we'll.
This is like meditation. Because you said you started off with heartfulness. And that was your main job, meditating. Now, meditation in theory should lead to connection with the oversoul.
Yeah.
The soul with the oversoul. That is what revelation is. I have tried for 40 years, 50 years, I have failed. So on what basis do I ask others to do?
Fair enough.
No. My passion was
Yes.
this.
Yes.
And I wanted to do PhD in comparative religion for this. ये तो agriculture में आ गए, पता नहीं करते थे.
Interestingly, there is another government policy.
Yeah.
Where they're telling the states that to the extent you reduce consumption of chemical fertilizers and subsidy saved on that
That's it.
will be shared with the states.
This is
But that scheme is known as starter because
PM
it will
Pranam.
be difficult to verify.
PM Pranam.
PM Pranam.
प्रणाम पे प्रणाम करेंगे और उससे ये दिखा सकते हैं कि this much fertilizer you can save, so उसमें से हमें दे दीजिए. And let's focus on one state. And Madhya Pradesh is a good state. ठीक है, who could volunteer? मैं अपनी टीम से बात करके I'll let you know and we can study and
And if you
jointly
have any
publish.
ICAR connections. तो
हाँ,
okay, then you can just
यहाँ बैठो
add
और
that.
करेंगे क्या?
बिल्कुल, मैं just.
Next up, 2nd of June, we are having a round table like this, where the former DDG of ICA
Okay.
will be here. Who is now the Director General of FAI,
Fertilizer Association.
Association of India. He was the DDG of Natural Resource Management. And
Till recently.
2nd of, and the topic is soil health,
You should be here.
improving soil health
Plant nutrition.
for better plant nutrition and human nutrition.
health.
That's great, perfect.
Okay.
Invitation भिजवा.
And the real focus is on chemical fertilizers more.
And there will be some representatives of fertilizer companies also, big ones.
हाँ, तो उसमें से companies भी आ रही हैं जो
You'll be here.
experiment कर रहे हैं.
5-6
You'll
of
be
them.
here. That'll be.
2nd of June.
No, there is a misimpression that they are not interested in anything non-chemical fertilizer. They themselves are fed up with this policy.
So,
They
I
will
mean.
rather sell half the material, but in a free market.
Yeah. They want liberation.
Who wants to collect 85% of their revenue from government of India?
Which doesn't have the
What
funds.
you have to do.
so they give up.
In some case, in some places, I don't know who was telling us that some fertilizer companies have bought over companies that are doing biochar because it became popular. I don't think in India, it was probably
No, there's
Japan.
something is going on.
that they.
There would be
and
hopefully
supplying both
the
things.
person, what was once Tata's plant, one of the best plants, bought by Yara. Yara is global second biggest company, I think.
The second largest
in the
fertilizer
world.
manufacturer in the world.
So that CEO will be here. Okay. And they are doing some customized fertilizers and very specific in UP. But they are more focusing in UP. So we can check on that.
Yes.
But this is where,
Yeah.
I'm committed. We know enough or reasonably well of the water plant. We have done on greenhouse gas emissions, full report. But soil specifically, I need to spend much more time and resources and the team prepared. Okay, and your biochar will be the base.
Would love to be a part of the journey.
Yes.
Thank you. This has been really enriching. Thank you.
Thank
Thank
you
you
very
so very
much, so kind of you, and thank you very much to those who are still online. Thank you.